Hi grade 11s. Before we go into the more past paper type questions, which are a little bit more complicated, I just want to do a couple of more examples of sketching hyperbole and exponential graphs and then finding the equation from the graphs. So this should be fairly quick. Let's have a look. The first question says, sketch the following graphs showing all asymptotes and intercepts with their axes. Right, let's quickly remind ourselves the shape of this. First of all, I hope you can see that this is a hyperbola, and the fact that this is a positive value means that my graph would probably be there and there. But this graph has been shifted. 1 unit left, 3 units down. So my asymptote is actually going to be at x is equal to -1 because I moved 1 unit left, and I moved 3 units down. So y is equal to -3, which actually means my graph's going to be there and somewhere there. So I am expecting an x and y intercept, and I can already see my asymptotes. So if I begin my neat graph on this side, don't forget that a scale isn't absolutely necessary. So as long as things look plausible, you don't actually have to measure centimeters. So if I draw a dotted line in here, this is my vertical asymptote, and my vertical asymptote is that x is equal to -1. Let's just remind ourselves why, because I moved 1 unit left. Or I could say to myself, what value of x would make the denominator 0, in which case the graph will be undefined. Okay, then I'm going to have a horizontal asymptote, which is your q value, so that's y is equal to -3. Just squeeze that in there. Let me raise it and write it a little bit better. Now notice your asymptotes we must always give an equation to. They are lines, which means they have equations. That's -3. Now my graph is somewhere here, as far as I know, and then there'll be some curve there, which means all I need to do is find an x and y intercept and then label them. Plus I probably should label a point on that naked branch, as I call it. So let's find my y-intercept first. Let's let x be equal to 0. So then f of 0, or the y value at 0, would be 2 over 0 plus 1, which would be 2 over 1, which is 2, and 2 minus 3 is -1. So this tells me my intercept is 0, -1 if I'm asked for a coordinate. If I'm not asked for a coordinate and I'm just actually doing a graph, you put -1 on your axis. Okay, let's find our x-intercept. In order to find our x-intercept, we're going to let y be equal to 0. So if y is 0, 0 equals 2 over x plus 1 minus 3. So remember, I like to put one term on each side before I multiply by x plus 1. So then that becomes 3. X plus 1 equals 2. So 3x plus 3 equals 2. 3x minus 3 from both sides, and divide by 3, which means that over there is -1/3. Now notice when I drew this, I didn't draw it to scale, or I didn't draw it particularly neatly. I just drew it and then I go label my points. We don't actually mind. That definitely isn't 1/3 of the way to -1, but we're not too panicked about scale. Okay, my last thing is I need a point on this graph. This branch here should actually have a point on it. So I'm going to say let x be equal to, and I would pick any number less than -1. So I'm going to pick -2. So that means y would be equal to 2 over -2 plus 1 minus 3. I'd pick up my calculator, but that becomes -5. So basically, there is a point which is -2, -5. And I should always have a point on every branch. And that's it. It's probably a 4-mark question, and all I end up marking is your graph. And so just make sure that you've drawn it and labeled all your intercepts and asymptotes. Okay, the next one, why don't you pause the video and try this one, and then you can have a look at the answer. Okay, I'm hoping that you've tried it. Right, let's get going. This is a negative. Now, does it matter whether the negative's outside or on top of my fraction? It doesn't matter where that negative is. Basically what it's saying to me is my graph should be there and there. But if I have a look at this, I moved 3 units right, so my asymptote is going to be there, and 1 unit up, so my asymptote is going to be there. So my branches will be there and there. So immediately I can go and start drawing my drawing, and then I'll work out my intercepts in a second in order to label them. So my graph moves 3 units right because there was a minus 3 in the formula, and so my asymptote is going to be at x is equal to 3. If x was equal to 3, my denominator would be undefined, my denominator would be 0, making the question undefined, which is why that asymptote exists. This is at y is equal to 1. Now I've already figured out that I think my graph is going to be there, because this is a negative shape, and there. So if I can go find my y-intercept, that'll be a wonderful point to label there. And if I can go find my x-intercept, that'll be a wonderful point to label there. And I actually won't land up having any naked branches. So let's go do that again. Let x be equal to 0 to find your y-intercept. So f of 0 would be negative 1 over 0 minus 3 plus 1. I would use my calculator, and my calculator gives me 1 1/3, or 4 over 3. Now again, I don't worry about scale, so I just write 4 over 3. Now that kind of makes sense because it must be above 1. If I was writing it as a coordinate, this would be 0 and 4 over 3. Okay, my x-intercept, I'm expecting a number bigger than 3, so let y equal 0. So 0 equals negative 1 over x minus 3 plus 1. I'm going to put this fraction on this side, so that when I multiply by x minus 3, it's fairly easy, and I get x is equal to 4, which I kind of had expected it must be bigger than 3, and so it makes complete sense. So just to do that a little bit more slowly, the trick here is I multiply by x minus 3 on this side so that it cancels, but then you multiply by x minus 3 on this side. And I prefer to do that only when there's one term on each side, otherwise I generally make mistakes. And so there's my hyperbola. Very cool. Okay, let's try an exponential. Again, try to do these by yourself, and then pause the video, do it by yourself, and then check if you're right. Okay, exponentials, I think drawing them is probably a little bit more difficult because finding the shape is a little bit complicated. Your base is 2, which means that's bigger than 1. It's an increasing exponential. Except it got reflected, because that's negative, it got reflected over the x-axis. So negative 3 means it actually looks like that. Except, one last thing, the entire graph moved up 6. So this asymptote, which would have been on my x-axis, actually lands up at 6. And my graph will land up like that. So immediately I can draw in what I know so far. Remember, with an exponential you only have one asymptote, and that's a horizontal asymptote, which is your q value. So immediately I can draw in a horizontal line. Notice I don't use a scale or anything, I don't measure, I just draw one in, and then I'm pretty sure that my graph looks like that. Now, unless it goes to the origin, there's going to be a y-intercept, which I can go and find, and then there'll be an x-intercept, which I can go find. In the unlikely event it goes to the origin, I'll need to go and redraw my picture. So let's find our y-intercept. Let x be 0. So what is h of 0? So that's negative 3 times 2 to the 0 plus 1 plus 6, which is negative 3 times 2 to the 1 plus 6, and oh gosh, what do you know? In the unlikely event, it has happened. 0, 0. When x is 0, my y value is 0, which means if this was me in an exam, I would need to go and erase what I thought the picture was. It is actually exactly the same shape. It just happens to go through 0. Oh, that's a terrible graph because it doesn't go through 0, 0. So let's try again. It goes through 0, 0. Now, if it does go through 0, 0, I'm not going to bother going to find the x-intercept again, because if I go find the x-intercept, I'm going to get 0, 0. So what I do actually need to do here is let's plot one other point on the graph. So I would just say, let x be 1. If x was 1, what is h of 1? That would be negative 3 times 2 to the 1 plus 1 plus 6, which will be negative 3 times 2 squared, which is 4. So that's negative 12 plus 4, negative 6. So the other point on the graph that I could label is 1 -6. But note, I don't draw to scale or anything. I just go and put that point on it. And there's my graph. So we were unlucky then that it went through the origin, but it's a really good one to practice, because mostly when it goes to the origin, we start to freak out a little bit. Okay, once again, you try this one, and then maybe pause the video and then have a look at what I did. Okay, this one is interesting, and the only reason why this is interesting and the reason why I chose this one is we're not used to a negative exponent. We don't like that at all. So what does this actually look like? A negative exponent means exactly the same thing as take it to the bottom and make it positive. Now, we would never write something like that. We'd rather write it as 1/3 to the power of x minus 9. Now, why am I allowed to do that? Well, simply because 1 to the power of anything would be 1. And so we can put that as 1/3 in a bracket. So just make a note to yourself, a negative exponent actually makes your base a fraction when you go and write it out with positive exponent. So a negative exponent actually implies your base is a fraction. Well, I should say a common fraction. So a fraction less than 1. So just be aware, because lots of people will see the base of 3 and think, oh gosh, it's an increasing function. So most people would have gone, 3, wonderful, it goes like this. Now it actually doesn't. Because it's a negative exponent, it's a fractional base, and it goes like that. So this is a decreasing exponential despite what it first looked like, except it's been moved down or translated down 9 units, which means unless it goes to the origin, it'll look something like that. So if I go and draw this, how I would in an exam, I would draw my horizontal asymptote at y is equal to -9. Again, no particular scale really. As long as you've labeled, that's terrible. As long as you've labeled in your asymptotes, you don't have to use a scale. And I have discovered that because it's a fractional base, my graph looks like that. So once again, I'm going to go find this x-intercept and label it. I'm going to go find this y-intercept and label it, and then my graph will be done. Okay, let's find our x-intercept first. Sorry, our y-intercept. Let's make x 0, because that's generally the easiest one to do. So that would be k of 0, which would be either 3 to the -0, if you wanted to do it like that, or you could say 1/3 to the 0 minus 9. Now you could use your calculator, but basically that's 1 minus 9, which is -8. So that is at -8. Now can you see my scale is definitely not right, but we don't really care. Okay, now I'm going to go find my x-intercept, so let y be equal to 0. So 0 equals 1/3 to the x minus 9. Or I could have said 0 equals 3 to the -x minus 9, whatever one you want. If I did this, I would now say that 9 equals 1/3 to the power of x, and then you'd want to bring the base to the top, so then you'd actually bring it to the top and make the exponent negative. So it actually might have helped to work with the original function here. Now hopefully you can see that 9 is 3 squared, and when you have the same base on both sides, your exponent is the same on both sides. So I'll end up getting x is -2, which does seem plausible because it's in the negative region. Now just to explain this again, if you went to this version, we need to bring the 3 to the top, so it's 3 to the -1. And now when I raise a power to another power, multiply. So I'll end up getting that. So actually the original version of this function was quite useful. Okay, let's move on quite quickly. These ones should be a lot faster because these are finding equations from a graph. So again, try this question and then maybe watch the video. So this question says, given h of x is a times 2 to the power of x minus 1 plus q. The line y is equal to -6 is an asymptote of h, p is the y-intercept of h, and t is the x-intercept of h. First question says, write down the value of q. Don't forget, q is your horizontal asymptote. My horizontal asymptote is y is equal to -6, which means immediately q equals -6. Okay, now it says if the graph of h passes through that point, now it's given you a point, calculate the value of a. So basically, can we find the equation of this function? So why don't you hit pause for a second and try this out. Okay, I'm hoping that you've tried it, in which case you will know that you have a times 2 to the x minus 1 minus 6. And you have a point on the graph, so I literally go and substitute that point in. Y is negative 21 over 4 when x is negative 1. And so this is a little bit annoying because it's got fractions, but it's not particularly difficult. This is a times 2 to the negative 2. Now, I would possibly add 6 to both sides so that I can do that. So I'm going to take negative 21 over 4 and add 6, and you'll actually get 3 over 4. And then if I change 2 to the negative 2 is 1/4. And so I can pretty much now see that a is 3, because I can multiply by 4 on both sides now, because they both have a denominator of 4. And if I multiply by 4 on both sides, they cancel, and I get a is 3. So basically, I have solved the equation of this function. So it's 3 times 2 to the x minus 1 minus 6. Right, let's go down to our last question, which is finding the equation of a hyperbola. The graphs below are of h, which is a hyperbola, and y equals x minus 3, which is one of the axes of symmetry of this function. The two graphs meet at f on the y-axis and then at 4, 1. The asymptotes of h are drawn. First question says determine the equation of h. So again, hit pause, try it out, and then watch. Okay, I'm hoping you've done that. I know that this graph is a over. Now, I clearly moved 2 units right because my asymptote is x equals 2. So if I move 2 units right, that must be x minus 2. And I moved 1 unit down, which means it's minus 1. That would possibly be 2 marks already. Now I need to sub in a point to solve for a because there's one unknown. 4, 1 is a point. So when x is 4, y is 1. I'm going to add 1 to both sides, and 4 minus 2 is 2, and I multiply by 2 and I get 4. So what is my equation of h? It's 4 over x minus 2 minus 1. Now let's just check, was I expecting a positive a value? Yes, I was, because the branches were in quadrant 1 and quadrant 3. So that makes sense. Now the next question says determine the equation of the other axis of symmetry. Again, try that out and then follow. Okay, 3.2. There's 2 methods to do this. You already have one of the axis of symmetry. One of the axis of symmetry was y is equal to x minus 3. The other axis of symmetry will be the negative gradiented axis of symmetry. So it's negative x plus c or plus d. So if you like the method of using the asymptotes, you know that there's a point of intersection of the asymptotes, which is when x is 2 and y is minus 1. Let me correct that. And when y is negative 1, and that's your point of intersection of your asymptotes. And guess what? Your axes of symmetry, both of them, go straight through that point of intersection. So when y is negative 1, x is 2, and if I add 2 to both sides, I get c is 1. So my other axis of symmetry is negative x plus 1. Okay, or if you prefer the other method says that your axis of symmetry should be at negative x, except whatever movements happen to the graph happen to the axis of symmetry. So it's negative x, and I moved 2 units right, 1 unit down. Now if I multiply out, I get negative x plus 2 minus 1, and what do you know? I get exactly the same answer. So there we go. Those were just 3 questions on quickly plotting a couple of exponentials and hyperbolas and getting equations from the graphs. These really are 2 of the nicest functions, and so they're worth working on and getting confident. Okay, now I think we're ready for the bigger, more complicated past paper questions.